Hello everyone, this is an RLC band stop circuit. It's incredibly small, but it does quite a bit. The components are this inductor, this non-polarized capacitor, and this resistor. We don't have any wires going to ground and positive right now, but that's alright. How it's supposed to work, using this image right here, is the AC source, which for us, we use this, which is just giving us the frequency. You can use just a regular 5-volt plug-in as well, but for us we're using this one, which comes out to 1.6 hertz. It goes to right here. Now it's called band stop because once it gets to here, it goes around and doesn't let anything through here. But that doesn't mean there's no current in it. The resistor makes sure that less electricity goes through it than it's supposed to. The non-polarized cap doesn't have a lot of moving through this either. The inductor is the one that keeps everything moving. For measurements, we took a look at resonance frequency, which is the resistance of the capacitor, which is this one right here, and the resistance of the inductor, which is right here. They both end up coming out to 1,000 ohms, and using that in this frequency right here, the resonance frequency, we got this. When they're both at the same, that's how much hertz we're getting, which is a 15, which is pretty close to what we were using for our source. It doesn't have to be exact to make sure it's not too far off. We also took a look at this, which is the full resistance of the circuit. So you get the resistor squared plus the resistance of both the capacitor and the inductor. Doing all that comes out to 1,000 ohms again. For the cutoff frequency, we had a lot of trouble with that, but what we did is we put this to the point where the O-scope had it at its lowest, and we added it up with our old one here, which puts it to around 3,000 hertz. This is an example of what happens right here with how the current goes, but then it stops and doesn't let anything through.